part of MAT exercise that help us find good enough answers to hard problems, especially when there is changing. It's used in science, engineering, and economics. One common technique is the least square method, which finds the best line or curve through a group of points by minimizing the total value. In our project, we use this method to estimate the perimeter of the leaf by looking at several points along the edge. Then, we compare it to the real perimeter with measure using string to see how close we estimate. First, to obtain the actual perimeter of the leaf with string-based measurement technique. Second, to correct the speed data points along the boundary for using the third, to apply the discrete least square method for perimeter curve fitting to the center data. Fourth, to estimate the least perimeter by evaluating the arc length of the fitting curve. Fifth, to compare the numerically estimated perimeter with the manual measurement and assess the method's accuracy. Step 1. Find perimeter of the object in the string and label it to set value. Step 2. Place the object on the graph paper, mark each point and record it in the next step. Break point, segment, then calculate the arc length of each segment. For segment 1, we take 2 points from A to B. Then, we find the summation of x, y, x squared, x cubed, x to the power of 4, xy, and x squared y. Then, we put all the summation into the least square formula. After that, we solve for coefficient A0, A1, and A2 using cross elimination method. After we find the solution, we put it to the least square function, and then we differentiate the least square function. After that, we use the arc length to find the unit for that 2 points. Step 2, we took from point B to point I, and then we find the all summation for x, y, x squared, x cubed, x to the power of 4, xy, and x squared y. And then we put all the summation into the least square formula, find the coefficient using cross elimination method, and then we put the solution in the least square function and we differentiate it, and then we use arc length to find the unit for that all points. We will find the length from I to Q, and then we find the summation of x, y, x squared, x cubed, x to the power of 4, xy, and x squared y. And then we put all the summation into the least square formula, and then solve for the coefficient using cross elimination method. After we get the solution, we put it in the least square function and we differentiate it. And using that least square function, we find the arc length to find the unit for all that points. Point Q to A, which is the starting point, and then we find the summation of x, y, x squared, x cubed, x to the power of 4, xy, and x squared y. After that, we put all the summation in the least square formula, then we solve for the coefficient using cross elimination method. After we get that solution, we put it in the least square function, differentiate it, and then we use arc length formula to find all the units for that point. Sum of the arc length for every segment. For step 5, after we get all the arc length, we convert the measurement using the scale y unit corresponding to 2 cm. We find the error by applying error formula. We take the exact value minus the approximation value divided by approximation value, and then we multiply by 100%. And then we get the error for this. For the result, the exact measurement with the string-based method, we get 47 cm. For approximate parameter, we are discrete method. For step 1, we get 1.84681148 units. For step 2, we get 9.38464258 units. For step 3, we get 11.290708 units. And for the segment 4, we get 0.321893 Next, total approximate perimeter, we get 45.684,703.5 percentage driven error that we get is 2.7985%. This project shows that discrete perimeter is a good way to estimate the perimeter of uneven shapes like this. The real perimeter was 47 cm, while our estimated perimeter was 48.68 cm, meaning a 2.7985% error. By using points along the edge and drawing screw thread, we got a close match to the actual perimeter. Computer tools like Nepal and Excel help us to do math and organize our data. The method was well in many areas, including science and engineering, and can help with the shapes that are hard to measure directly. Despite some challenges, like needing good points and handling both X and Y errors, the method gets us a simple and accurate result. The discrete square method is a strong and accurate way to estimate the parameter of uneven or irregular shapes. In this project, the method gets a result that was only 2.7985% from the real value measured using string. This shows that it works well for a real-life shape problem. Us for this project. Thank you very much for watching.